We are currently in the middle of the most expensive game of capture the flag in human history. The flag is a set of titanium tubes filled with Martian regolith, and the finish line is a high-security lab on Earth. While NASA has been methodically caching samples with the Perseverance rover, the logistics of getting those samples off the surface has created a vacuum that China is moving to fill with surgical precision. To understand the challenge, you have to look at the Mars Ascent Vehicle. This is a rocket that must survive a 7-month deep space transit, endure a violent landing, and then maintain its fuel integrity in a -60-degree environment. NASA's current design is a 2-stage solid fuel rocket. It is essentially a high-tech firework that has to work perfectly the first time, because there is no ground crew on Mars to hit the reset button. The ladder of complexity starts with the launch. Earth's atmosphere is thick, but Mars's atmosphere is just 1% as dense. This sounds like an advantage, but it means parachutes are nearly useless for heavy payloads, and wings offer no lift. You are landing and taking off in a near vacuum using pure propulsion. NASA's architecture involves 3 separate launches, one to land, one to fetch, and one to wait in orbit. It is a synchronized orbital dance that leaves zero room for error. China's Tianwen-3 mission takes a different approach by consolidating the hardware. They are favoring a dual-launch architecture using the Long March 5 rocket. One launch delivers the lander and the ascent vehicle, while the second delivers the orbiter and the return capsule. By reducing the number of independent moving parts and autonomous handoffs, they are trading scientific volume for mission speed. Then there is the orbital rendezvous. Imagine 2 sniper bullets colliding in midair, but one of the bullets has to catch the other. The ascent vehicle must meet the return orbiter in a precise low Mars orbit. If the timing is off by a fraction of a second, the sample container becomes a permanent piece of space junk. China is betting on a simpler, faster docking sequence to shave years off the timeline. The most surprising contrast lies in the return phase. When the samples approach Earth, they will be traveling at over 11 kilometers per second. NASA is designing a high-stability capsule that can survive a hard landing in the Utah desert without a parachute to eliminate another failure point. China is iterating on their proven Shenzhou return technology. They aren't trying to reinvent the wheel. They are just trying to get the wheel back to the garage. The why it matters is not just about bragging rights. The first nation to analyze these samples will control the narrative on whether Mars once harbored life. They will be the ones to identify the perchlorates and salts that will dictate how future human colonists survive. NASA is aiming for the mid-2030s, but China's window opens in 2028. In orbital mechanics, timing is everything, and the window is closing fast on American dominance. So, is a simplified mission more likely to succeed than a perfect one? The history of engineering suggests that complexity is the enemy of reliability. Hit the like button and subscribe for your weekly sprint through the future of space. If you had to bet your tax dollars on one mission, would you choose the complexity of NASA or the speed of China? Let us know in the comments. The race is no longer about who gets to Mars, but who manages to leave.